Hey all, welcome back to my channel. So in the previous session we have discussed about associative arrays. So what is the need of associative array and what is the flexibilities and what are the advantages in associative array compared to that of dynamic array. Okay, so in order to know about what is associative array, first you should know about dynamic arrays and what are arrays. So I'll link everything regarding arrays in the description box. You can go check them out there. Like I have done 2 or 3 videos on arrays itself because arrays are really important in system Verilog. So you need to know them carefully because in most interviews also without at least one question on this array there won't be any interview. So that is why if you are seeing first this video, then go check that videos that I have linked in the description box and then come here. Okay, so in today's session we are going to discuss about associative array methods. Okay, in the previous session I have told you we are having various methods in associative array. So we are going to see them one by one with an example so that it will be easily understood for you. Okay, let's not waste any more time. And also if you are new here, consider subscribing my channel and hit on the notification bell. And I am a VLSI verification trainer who will be uploading sessions on Verilog system, Verilog and UVM, which is concerned with all the front end design and verification courses. Okay, so and also follow me on LinkedIn and all the social media channels that I have uploaded in my channel. Okay, so coming to the associative array examples. So this is my first example. Here in this first example I will be using some methods like NUM, number, first method, last method. Okay, in the next example I'll be using some more methods. Okay, so I'm dividing it partwise so that it will be easily understood for you. So this is my associative array example. So module associative array int a array of star. If you see this here, I have spoken about this star in the previous session. Okay, you can go there and check it out. So int array a array of star. Okay, and then int index. So this is my associative array declaration. Okay, and then initial begin. I am repeating this particular two statements for three number of types. Okay, you already know about this repeat since you already I think you already seen about Verilog sessions. So there I have explained all these loops. Okay, so repeat 3. I am repeating these particular two statements for three number of times. Now I will be displaying the particular thing here. If you see here, dollar display number of entries. So in order to know number of entries, nothing but in order to know the size of the array, we can call it as like that. Number of entries means nothing but, for example, if this is my array, okay, the elements within this array is called as number of entries. So in order to know what are the number of elements, that means how many memory locations is being allocated, you will be using the name of the array. What is the name of the array here? A array. So a array dot num. Okay, in order to know number of entries, right? And then for each array I, okay, a array of I think you already know about this for each loop. So for each of this associative array I want to display all the elements. Okay, so what are all the elements? I didn't give any elements. If you see here, actually in associative, either in associative or a dynamic array, you will be giving assigning elements in this format. Is it or not? Like tick, and in flower braces you will be giving like some 1, 3, 4. These are some values you will be giving. But if you see here, I have not given any assignment. Then what are the elements that I am talking about? If you see here, I have given a repeat loop where I am assigning some elements with a help of logic. Okay, instead of assigning them directly, I am assigning them with some logic here. Okay, so this is how I'm assigning the elements. So I'm talking about those elements. In order to know how many elements I have assigned, and in order to see the elements, I am giving these two display options. Okay, and then okay, within this, after assigning all the values, okay, for example, if you see here, from this you can understand that means repeat 3. That means from this you can say that I am having 3 elements. Is it or not? Okay, so among these 3 elements, what is the first element and what is the last element? Okay, now you can get it out, like since there are only 3 elements, is it necessary to know what is first and last? Because we can manually see it. Okay, But that is not the case. Since this is an example, just see it as an example. Okay, just like when you are a child, or when you are a toddler, ABCs are very difficult for you, alphabets. But when you reach that stage, when you have uh, left that stage, then that is easy for you. In the same way, basically, when you are at the starting stage of learning arrays, I'll be giving these examples, but that doesn't mean these examples are the only thing that we'll be using in our logic, or that you'll be using in the real time. Okay, so basically, you are designing a code. That means your code will be very vast, and when you are when you are assigning some elements in the array, that array may be very huge. Okay, that the size of the arrays may be very more than you think. As you already know that in the starting itself I have told you, associative array is mainly used where the memory allocation is sparse, that means very large. So among that very large memory, in order to check which element is in which memory location, so in order to know all these things, you will be using this particular array methods, not for taking three elements in order to see first and last element of among these three elements. Okay, this is just an example, but we I'm by using this example, we should understand that, okay, by using this method and by writing it in this syntax manner, you will be getting this particular value. Okay, from by using the dot first, you will be knowing what is the first element that is assigned, what is the last element that is assigned, so what is the previous element, and does that element really exist or not. So all these things you will be knowing. Okay, clear? So now coming to this example. So in among these three elements, what is the first element? For that you will be using dot first of index. Okay, for the last element, dot last of index, array name dot last of index, array name dot first of index. Okay, clear? Now let us see what are the elements within this, what is the logic we are writing here. Okay, so repeat 3, that means these two statements will be repeated for price. So for the first time, okay, array of index. Since I didn't give any value to the index, basically its default value will be 0. So now the index is 0. So array of 0 equal to, what is the index value? 0. 0 into 2 is obviously 0. So now what is the index value here? That is 0. So 0 plus 4. So what will be the index value? In the second statement, the value will be 4. So now what will be displayed as soon as the first repeat option is completed? That is array of 0 equal to 0. Okay, this is my first thing. Okay, so this is printed because I am printing I and a array of I. So at first I is 0 and a array of I is also 0. Okay, and then coming to the next step. Okay, when it again the second time when it is looping, what is happening? A array of, now what is the index value here? 4. So 0 is replaced with 4. So a array of 4 equal to, okay, so what is the index? 4. 4 into 2. So obviously 8. That is printed here. Okay, so see, first output is AR of 0 equal to 0. That means here that is 0 and then here it is 8. AR of fourth location. Okay, so this is my 0th location, this is my fourth location, and this is my next location. So what is the next location here? If you see, now here AR of 4 is 8. Now what is the index value? 4. So 4 index value is nothing but 4 plus 4. So which is the next, what is the next time? That means what is the third index value? That is a array of 8. Got my point here? Yes, a array of 8. So for this a array of 8, 8 into 2, nothing but 16. So this is my next element. So 0, 8, 16. What is this location? This is 8th location. Okay. So total my size of the particular thing is 3. That means 3 entries. Okay. That doesn't mean the size is 3, but there are only 3 entries. Okay. So 0, 8, 16. Why we will only consider entries? Because I already told you in the starting itself, associative array, in the associative array the memory is allocated as soon as you call that particular array. That means whenever you are calling this memory location A array of 0, then memory is allocated to only A array of 0. Similarly A array of 4. Similarly A array of 8. But this is the difference when it comes to dynamic array. That is what we have talked about in starting itself. That means in dynamic array the memory location is continuous. That means when you are giving, like for example, new of 6, then that means 0, 1, 2, 3, 4, 5, 6, all these memory locations. So 0, 1, 2, 3, 4, 5, so all these 6 memory locations are being created, okay, in the runtime in case of dynamic array. But that is not the case in case of associative array. In associative array, this is what is happening. As soon as you are calling A array of 0, then A array of 0 memory location is created. A array of 4 you are calling, fourth memory location is created. So that is why in associative array the memory locations allocations is not continuous. If you see here, this is the 0th memory location, and then 4th, and then 8th, and between 1, 2, 3, 4, these are all not created because they are not being called. Got my point? So this is the main difference between associative and dynamic array. Now hope you got how these elements are being solved here. Now among these elements I want to know what is first. Now if you see, what is the first element? It is A array of 0, which is 0. Okay. And what is the last element? A array of 8, which is 16. Got my point? Yes. So for this same thing, like for these three things only, okay, like what are my elements now? 0, 8 and 16. What is the memory locations? 0, 4 and 8 memory locations. Okay, so these are my indexes. Okay, remember that this is index and these are elements. Okay, clear? Yes. So for this I want to apply some more methods also, the same logic here. Okay, but only thing is I have just used other methods also. So if you see here, what is my next method? Exist. That means I want to know whether that particular element is being existed or not. So for that, if array name dot exist, and here exist means you need to know which element is being existed, if that particular index is being existed or not. Okay, so I will be giving index number. Okay, if you see here, array name dot exist of that particular number or that particular index you can call. Okay, so if you see here, is the index name numbered 8 is existing, so these are indexes. So 0, 4, 8, so 8 is being existed, so that is why this is displayed. Index 8 exists in array. If this is not existing, then this particular else, we have also written else, so else statement will be displayed. Okay, index 8 doesn't exist in array. Clear? So this is about exist. And coming to last, you already know about the last. Last is nothing but, if you see here, array of 8 which is 16, that is the last element. In order to know the last index, okay, you can go for index either for first index or last index, and then coming to previous. This is really important because last and previous is different. Because if you see here, this is my last index. What is the last index? Which is 16. Now my pointer is at this particular memory location. Okay, now as soon as you are giving the previous after this particular method, then that means from where my pointer is being existed, that previous element. Now my pointer is at this memory location. Now what is the previous for this? Which is 8. So it will be checking the previous element, which is entry is a array of 4, which is 8. So this is my previous. Got my point? Okay, so this is my 16. The 16 is my pointer is at this 8th memory location, and then the previous to that 8th memory location is 4. So 4 is being displayed. Okay, that is about previous. And coming to next. Okay, what is next? Now where is my pointer? My pointer is at 8. Okay, it has come from 16 to 8. Is it or not? Now from 8, what is the next position? Obviously 16. So It is in this way. Here, previous and next indexes will be based on where your pointer is at that particular memory location. That means at which memory location is your pointer is, based on that it will be checking that next and previous options. Okay, so this is about previous and next memory locations, right? So I think you are clear about this particular thing, but if you are not clear, more clear about this, okay, I want to explain it to you with an another example for you in a more detailed manner so that you will be easily understood. Okay, so if you see here, this is my particular array. So in this array I have given like these values, like if you see here, array of 2, 4, 6, 8 and 10 and 12. Okay, so these are my five option, these are my five arrays in this way. That is what I told you. If you see here, I have taken random memory locations. These are not continuous. That makes the difference between associative and dynamic array. Okay, so in the fifth memory location I am assigning value 2, in the 10th memory location I am assigning value 4. So in this way, in some random memory locations I am assigning random values. Okay, so after that I want to display all these values. Okay, that means I want to display all these values, for which I have used a for each loop here in order to display all the values. So after displaying all the values, in order to know the size and as well as number. Okay, size is different from numbers. Okay, numbers means number of elements that are there in this. Because why is it different? Because even though the size is this much, like if you see this, the size of this is 1 2 3 4 5 6. Okay, even though the size is 6, you may even you may assign the values, or you can just create the allocation, you can just create the memory and leave it just like that. Okay, leave it empty. That is also possible in associative array. That is why the number is different from size. Size means number of what is the indexes. Okay, size refer to, just remember it like this, size refer to indexes, whereas NUM refers to number of elements within that particular indexes. Okay, you can just remember it like this, right? So this is how the thing is. So for this I am taking array of size as well as array of number also, right? And then I am using some methods. Now if you see, what is my first thing? If you see, if array dot exists 7, that means I want to know whether 7th index is being existed or not. It is being existed. Okay, so this is my question here. If array dot exists 7, then it will be displaying 7th index is existing, or else it will display 7th index is not being existed. Similarly, I am checking for 8th memory location also. Okay, and then after that I am applying various methods like first, last, okay, previous, next. For previous and next, I didn't leave it for the pointer itself, but I am taking my pointer to particular location called 9, and then I am telling to check what is before 9. In the similar way, I am taking my pointer to 10 and I want to know what is after 10, 10th memory location. Okay, clear? And then after this I am delaying particular like index called delete of 7. If you see here, there is 7th memory location here, so I want to delete only this particular memory location, so I am doing that here. Okay, array dot delete of 7. So after deleting, I want to display again the remaining elements, like after deleting it I want to display all these elements. Clear? Yes. And then coming to next thing, I am deleting the entire array after this. So after deleting the entire array, I want to know the size of that particular array. Since you're obviously, since you are deleting it, there won't be any size. Now let us see what is the output for this. So if you see the output, first we have displayed all the elements. So what are all the elements? 5, 7, 9, 10, 13, 20. So all these elements are being allocated for the site. That means all these memory locations are being allocated, and these are the values that are assigned into this memory location. So after all this, what is the size? Size is 6. And obviously, since you have assigned for every value, so the number of entries is 6 as usual. Okay, now I am asking whether an element is being existed. That means, is the seventh memory location being assigned or not? So in this way, I am checking whether something is exist in that particular memory location or not, so that I can assign some other value to that memory location. Okay, so for this, I am checking the array of 7. It is telling that yes, there is some element in the seventh memory location. Now an element doesn't exist at index 8 because I have not taken any index 8. So since there is no memory location, so there is no element in that particular memory location. Okay, so now what is the first index, which is 5? Okay, what is the last index? 20. Now I have, in the program, if you see, I have taken my pointer to ninth memory location, and I am asking which memory location is before this ninth memory location, that is 7, and I am wantingly taking my pointer to 10th memory location, and I am asking about the next of 10, which is 13. If you see here, yes, clear, right? And then after deleting, I have deleted one element like 7. So after deleting that particular element, if you see here, this particular location is being deleted. So 5, 9, 10, 13, 20, the remaining elements are being displayed. So after this, what I have done, I have given a method called delete dot array. That means I have deleted the entire array. So since I have deleted the entire associative array, obviously the size is 0. Okay, hope you got about this difference between associative and dynamic array, and also clear about how you will be using these methods on associative array. Okay, if you are having any doubts regarding this, you can ping me in the comment box, so that if you want some more explanation on this or some more examples on this, please ping me in the comment box. I will definitely explain you with more examples if you are needed. Okay, and also if you are having any doubts on any other topic also, like what I have explained, not what I am going to explain, because what I am going to explain, I will be explaining it. If you follow me on LinkedIn, I have given you some course structure, so based on that I will be uploading the sessions based on that. But as far as now, what I have explained, if you are having any doubts on the topics that I have already explained, and if you didn't understand, then you can ping me in the comment box. Okay, if possible, I will explain it another time. And if it's just it is a those are small doubts, then I'll be clearing the doubts in the comment section itself. Okay, that is all for today. Thank you.